Okay, in this video we're going to go through some very basic questions on simple circuits. So starting with question 1a, which of the above circuits would actually work, which means the bulb would light up? So A, B, C or D? The answer here is B. And the reason for that is basically that it's the only one where there's a complete circuit and the bulb is actually a part of the circuit. So C and D also have a complete circuit, but electricity would just go straight through the wire. The bulb is kind of attached onto the side of it. Electricity wouldn't actually flow through the bulb. So again here D, you can see electricity would go through this wire, and electricity always takes the path of least resistance. So if it's connected directly onto this other wire, it would just flow straight through there. We actually call that a short circuit because it can just bypass the bulb and go straight through the wire here. So the answer here is B, because the bulb must be part of a complete circuit. Alright, so moving down onto some of these problems down here, we've got some pretty complex looking circuits. I'll just clear that other stuff so it doesn't move with us. Sorry, just give me a sec. So looking at some of these slightly more complex circuits here, A, B, C, D, E, and F. The first question is just to identify which of these are series circuits. Okay, so if we look at them, a series circuit is literally a single pathway where electricity would flow out one end of the battery through the circuit and simply return to the battery in a single pathway. So it goes through the components in series, one after the other. So essentially if we look at A here, this would be a series circuit, so it flows through one component, the next one, and around. So we would say this one, yes, is a series circuit. B, there is a series loop to it here, but it also has a parallel section. So we could say that this resistor here and this resistor here are in series with each other, but this other one here is in parallel, so it's not a complete series circuit. Or it's not just a series circuit. C, if we follow this, we can follow a single pathway around. So we're going through one resistor, through the next one. Doesn't really matter which way around we go. Through the next one, we've got a single pathway. So yes, again, we could say this one is a series circuit. So if you can trace round in one go and cover the entire circuit, then it must be series. Okay, so if we look at D here, we can come out of the battery and I could go around this way. Alright, so we've got a loop there, but I've got an alternative loop. I could go through the other way. I could go through this one or through this long way here. And so this is not a series circuit. E, again, so if I follow that through, I could go through one loop, or I could go through the other resistor, or I could go through the third one there. There's three different options, so those are in parallel with each other. And F, even though there's a switch here, when the switch is closed, we can go through this in one loop, one go. So yes, this is a series circuit too. So A, C, and F are our series circuit. So that's it. I will. We'll do 2B and 2C, and then we'll do the others in a separate little video. So let's add a voltmeter. So how do we add a voltmeter to the circuit? So we're doing this, it says add a voltmeter to circuit A, the first one here, that could be used to measure the voltage drop across one of the resistors. So I'm just going to pick this one. Remember, when we use a voltmeter to measure voltage, voltage is the amount of energy that's gained or lost as the electrons flow through any component. So as the electrons flow through the battery, they gain energy, and as they flow through a resistor, they lose energy. And so a voltmeter is always kind of strapped on like this. So it's just a circle with a V. And I often say to students, voltmeters have legs. They stand on the shoulders of other components. So the voltmeter kind of clips on like that. And it has to, because it's actually comparing how much energy the electrons have on one side and how much they have on the other. You wouldn't actually be able to see how much they lost if you just looked at the energy on one side. So a voltmeter needs to connect on either side of a component to see how much energy the electrons, the electricity has gained or lost. So 2C, add an ammeter to circuit A that could be used to measure the current flowing through the circuit. So I'm just going to put it over here. Essentially, an ammeter just goes within the circuit because it measures how quickly the electrons are flowing through. So an ammeter, I often say ammeters have arms because they go within the circuit, and essentially they just measure how quickly the electrons are flowing through. So how many packets of electrons flow through each second. So voltmeter measuring the energy gained or lost by the electrons as they go through something. Alright, so comparing how much energy they had before and after, and an ammeter measuring how quickly the electrons are flowing. So voltmeter measuring voltage and ammeter measuring what we call current. Okay, so hopefully that covers a few of the basics, and we'll get into a few slightly more complex things in the next video clip.